Imagine floating alone in the vastness of space. No sun to orbit, no warmth, no light. Just endless cold and darkness. Sounds like the setting of a sci-fi horror movie, right? But this isn't fiction. These are rogue planets, real lonely wanderers drifting through the galaxy without a parent star. They're also called interstellar planets, nomad planets, or even orphan planets. And scientists now believe there could be billions of them, silently roaming the void. So what exactly are they? Simply put, a rogue planet is a planetary mass object that doesn't orbit a star. Instead, it moves freely through interstellar space, carried by the gravitational currents of the Milky Way. And yes, this flips everything we thought we knew about planets. Until recently, we believed all planets had to orbit a star. After all, that's what planets do, right? Well, the universe is more chaotic and more exciting than we ever imagined. There are two main ways a rogue planet can form, and both are mind-blowing. Imagine a young star system in its chaotic infancy. Planets are forming, migrating, and fighting for space. Sometimes this dance gets violent. If a massive planet, like a gas giant, gets too close to another big object or interacts with multiple planets in a gravitational tug-of-war, it can get flung out of the system entirely. Boom. No more star. Now it's a rogue. This is called gravitational ejection, and it's probably the most common cause. It's like musical chairs with gravity, and the loser gets thrown into the void. Some rogue planets may never have orbited a star at all. Instead, they form the way stars do, from collapsing gas clouds, but they don't gather enough mass to ignite nuclear fusion. They're like failed stars, too small to shine, too big to be just rocks. This blurs the line between planets and brown dwarfs. Some astronomers even debate where to draw the line. But either way, they're out there, floating in the dark, unloved by any star. Now here's where things get crazy. Astronomers used to think rogue planets were rare, but with better technology and surveys like microlensing observations in astrophysics, MOA, and OGLE, optical gravitational lensing experiment, we've found evidence that they could be as common as stars, or even more so. That means there might be hundreds of billions of rogue planets in our galaxy alone. Let that sink in. More homeless planets than stars. Entire galaxies filled with invisible travelers. The most famous discovery came in 2011 when scientists announced the detection of 10 Jupiter-sized rogue planets, all within a relatively small patch of the sky. Since then, more have been spotted, some possibly smaller than Earth. And remember, these planets are invisible to our eyes. They don't shine. They don't reflect much. So finding them is like trying to spot a black cat in a coal mine during a new moon. The fact that we found any at all means there are probably countless more hiding in the dark. Now here's a question that blows minds. Can life exist on a planet without a star? At first glance, it sounds ridiculous. No sunlight means no warmth. No warmth means frozen oceans, right? Not necessarily. If a rogue planet is big enough, it might have a thick atmosphere rich in hydrogen that traps heat like a giant thermal blanket. Combine that with internal heat from radioactive decay or residual core energy, and you get a world that could maintain liquid water beneath its surface. In fact, it could resemble Europa or Enceladus, moons in our own solar system that may have oceans under their icy shells. And if there's water and a stable environment and chemical energy, well, life doesn't always need sunlight. Deep-sea creatures on Earth thrive in pitch-black vents with no light at all. So yes, it's speculative. But some scientists believe rogue planets could host subsurface life. These planets could be floating incubators, carrying life across the galaxy for billions of years. Life that doesn't need the light of a sun to survive. Detecting a planet that doesn't orbit a star is like trying to photograph a ghost in pitch darkness. It's no surprise we didn't even know rogue planets existed until recently, since rogue planets don't emit light and don't reflect a star's light. The usual methods we use to find exoplanets, like transits, where a planet passes in front of a star, or radial velocity, where a planet tugs on its star, don't work here. So how do we find them? This is where physics gets clever. When a rogue planet passes in front of a distant background star, its gravity bends the star's light, acting like a cosmic magnifying glass. The star briefly appears brighter. This is called gravitational microlensing, and it's the best method we have to detect rogue planets. But here's the catch. These events are incredibly rare, last only days or hours, and require massive amounts of sky to be constantly monitored. Surveys like MOA and OGLE have captured some of these fleeting moments, giving us a glimpse of the invisible population of rogue planets. There are even proposed missions like NASA's Nancy Grace Roman Space Telescope designed specifically to hunt for them. We're entering a golden age where the invisible is becoming visible. Let's imagine something wild. You land on a rogue planet. First of all, darkness. The sky above you is pitch black. No sun, no blue sky, just endless night. Stars might still shine above, but the planet itself would be plunged into an eternal twilight. And the cold? Brutal. Without the warmth of a nearby star, surface temperatures could plunge to hundreds of degrees below freezing, unless the planet has a thick atmosphere. But wait, what if it does have an atmosphere? Some rogue planets, especially massive ones, might retain a dense hydrogen-helium atmosphere. If that atmosphere traps heat from internal sources, like residual formation energy or radioactive decay, the planet could be surprisingly warm on the inside. Below a thick icy crust, you might find liquid oceans, much like the hidden seas of Jupiter's moon, Europa. So, standing on the surface might be impossible. You'd probably fall into a cracking ice shell, surrounded by the eerie sounds of an active, underground ocean. No sun, no day-night cycle, just geothermal echoes in the abyss. And if there's volcanic activity, you might see glowing lava-like vents, the only natural light for millions of kilometers. It's like standing in the belly of a sleeping beast, wrapped in silence. Let's go full sci-fi. What if our Earth got knocked out of the solar system and became a rogue planet? Surprisingly, it's not totally impossible. A nearby supernova, a passing star, or a massive planetary collision could theoretically disturb Earth's orbit, though the odds are astronomically low. But if it happened, everything changes almost instantly. Within days, global temperatures would plummet, crops would die, the oceans would begin to freeze from the top down. Within months, Earth would become a giant snowball. Only geothermal heat, volcanoes, tectonic activity, and the planet's hot core would provide any warmth. Some humans might survive in underground bunkers, heated by nuclear power or geothermal vents. Deep-sea life around hydrothermal vents could still thrive, just like on real rogue planets. With no sunlight, artificial light becomes the only source of day. Time would lose meaning. Days and nights would no longer exist. Could life survive? Possibly, but humanity would be forever changed. No longer creatures of light, but children of the dark. Now, let's go even deeper down the rabbit hole. If rogue planets can maintain heat, liquid water, and chemical energy, then they could theoretically host life. But here's the wild part. They might also be perfect places for alien civilizations to hide. Think about it. No nearby star equals hard to detect from afar. Internal heat equals possible subsurface habitats. Thick atmosphere equals protection from cosmic radiation. Mobile equals constantly drifting, making tracking nearly impossible. Some speculative theories even suggest advanced civilizations could intentionally move planets, or use rogue planets as stealth habitats. It's a stretch, but not impossible. After all, Earth is a bright signal in the dark. A rogue planet would be the opposite, a silent world wrapped in mystery. If aliens wanted to go undetected, this would be the place. Here's the most beautiful idea to end with. We often think of the galaxy as a giant collection of shining stars. But what if we're missing something? What if the true mass of the Milky Way, the real story of the universe, is written not in light, but in darkness? Rogue planets might make up a massive portion of the unseen mass in our galaxy. We can't see them, but they're there, drifting between the stars like forgotten notes in a cosmic symphony. They're a reminder that the universe is still wild, untamed, and full of secrets. And the more we learn about them, the more we realize we've only just begun to explore the dark. So next time you look up at the night sky, remember, it's not just stars up there. It's rogue worlds, planets without homes, stories without stars, waiting for us to discover them. If you enjoyed this journey through space, hit that like button, subscribe, and don't forget to share this with your fellow space explorers. See you in the next video, maybe one where we finally land on one of these mysterious wanderers.